Hello and welcome. My name is Dustin Kirkland. I'm a product manager at Google Cloud, and I have the privilege today to speak with two of my colleagues here, Justin Santa Barbara, also an engineer in Google Cloud, and we have a guest speaker, a customer of ours. Twinkle Desai is the VP of Technology at Kohls, and she's going to introduce the concept of multi-cloud and how that applies to her organization. I'll hand this to you, Twinkle.
Thank you, Dustin, for having me. Thank you guys for attending this. Kohls is a retailer and a tech company. We love technology. We have huge appetite to invest in technology and roll out to our customers. Our goal is to have a seamless customer experience. My team focuses on building environments and systems to support this ecosystem, which is resilient, highly available, highly secure, cost-effective. And we make sure that we reach out in the industry to understand the cutting-edge technology, which can bring value to add to our goals of having that seamless customer experience. As a retailer, it's very critical to make sure we support the burst traffic during our peak holiday season, which is Black Friday and Cyber Monday. So, to ensure that we have a solution which is not only cost-effective, secured, but also low operational cost, we need to make sure that the system is end-to-end integrated. As a Kohls, we also ensure that we are just not a problem solver, but also a forward thinker. So when we talk about multi-cloud strategy, we have to ensure that we meet our checklist. We came up with an expectation tree. It's very important to know what is a multi-cloud strategy we want to use and what do we want to achieve through this. Our checklist included the cost-effective solution, secured, highly available, burst traffic support. Make sure that it's a centralized operated solution so that we don't have to work with multiple tool sets. So when we looked at various products, for us, NTOS, which is a multi-cloud Kubernetes, seems to be a perfect fit. And that's where we started working on collaborating our multi-cloud strategy, where we are running multiple payloads in different cloud solutions. We have 100+ containers and 5,000+ containers across for stores and digital strategy, running 150+ microservices. We want to ensure that we still continue to deliver that seamless customer experience while having the ability to support the burst traffic as and when needed. So, NTOS was the right solution for us. And currently, we are working to integrate the entire payload for digital and stores on this ecosystem. I will invite back Dustin to deep dive into this product and help us understand furthermore. Thank you.
Thank you, Twinkle. I think the presentation that Twinkle gave here really actually gives us a good starting point and a concrete set of examples where multi-cloud and having a multi-cloud strategy is essential to business continuity and success, and what it takes to transform a business that's been around for a long time to really operate well and efficiently in a truly new era. And so here I have to speak with you about a handful of strategies that we think we can actually help with. And I'll start here. This is something that I hear from every single customer that I talked to in 2019. A little bit last year. Last year was a lot about hybrid cloud, trying to get to a hybrid cloud point. And maybe 10 years before that, it was just about getting to cloud at all. But today, every time I talk to a technical leader of any kind in any organization, the question really comes up, yeah, Google Cloud is great, but how do these solutions fit into a truly multi-cloud or architecture? And I think we can look at it and start here. And we can think about hybrid cloud as the bridge between using a public cloud and a private cloud. But multi-cloud is that and an extra dimension, which means actually working with multiple public clouds. Public clouds that are, in many cases, competitive, and that's actually essential to one of the tenets of the multi-cloud architecture. In this case, last year at Google Next, Google took the remarkable step of bringing GKE on-prem into the enterprise data center. And now we have quite a number of customers up and running with Google Cloud technology running inside of their private cloud environments. And the response has been tremendous. And that's just the starting point. That's really just the starting point. And I think we'll get into what that means. But before we go there, I want to sort of double down on Twinkle's display of the tree, the decision tree as to why go multi-cloud. And I've sort of boiled these down into 5 or 6 points, 5 or 6 bullets, every one of which we've got tremendous experience helping our customers solve one or more of these problems. So why multi-cloud? That might be on some people's minds. Maybe if you're here already, you're interested in how Google helps with this. But let me just make sure that we start with a taxonomy, with a set of reasons and motivations to ensure that we're on the same page. And I'll start at the top, being able to utilize more capabilities. Not every cloud has every feature as every other cloud. And in some cases, you're using one cloud for a particular feature or two, and then another cloud for another. Now, you could take a least common denominator approach and ensure our greatest common denominator approach and ensure that you're using the greatest common aspects of each cloud so that you have perfect portability. And that makes sense for some workloads. There are other workloads, though, that you may want to really focus in on a particular offering. Maybe you've got some specialized AI ML work, or you need a very specialized database or something else, okay? So being able to really tap into the unique characteristics of a cloud might be one reason why you need to use more than one cloud, because maybe your first cloud didn't have one aspect or another. The second is access to more geographies, and there are lots of reasons why you might need access to another geography. Some of the customers I talk to, especially in the gaming industry, need to have their data really close to the users playing those games. It's a latency. It's a laws of physics problem at that point. Shaving down to milliseconds or microseconds of latency is important in the AI, in the AR, VR, augmented reality, virtual reality world, or some of the gaming world. But it's not just there. It's also in banks and fintech. We see data that cannot move from one geography to another. And all of these are reasons why a multi-cloud approach might actually be the right answer. In some cases, it's a private cloud running in certain geographies. In other cases, it's a matter of using one or more clouds to supplement those geographies, being able to ensure that you can run those workloads in a place where one of the public clouds doesn't exist, it doesn't have a presence. Now, the data gravity problem is also one that we hear quite a bit about. And we see the data gravity problem across all industries. I'm working with a couple of oil and gas companies where this is really what it's all about. Same with the auto and the self-driving car industry. There's so much data that is resident in one cloud or another. Meanwhile, there's other work that happens in a different cloud or on-prem or in a car or on an oil rig or somewhere else. And yet, crunching that data close to that data is essential to these algorithms even working. And so having a multi-cloud strategy to solve the data gravity problem, your data is here, but something else needs to happen somewhere else, is another driver for going multi-cloud. Reducing vendor dependency it comes in a lot of different shapes and forms. In some cases, it's a matter of having the ability to negotiate on prices in bulk, although that goes both ways. Sometimes it's better to go all in on one cloud and get as much bulk discount as possible. In other cases, just having multiple vendors is something that I think we've learned over the last couple of decades of enterprise software and buying software as a service. Sourcing from multiple vendors certainly gives the buyer certain advantages. But it's not just that, it's also reducing the risk around one vendor failing or going down, spreading a workload across multiple clouds and load balancing across. That's something that I've worked with a number of startups that grow to a certain size and then become pretty essential, too big to fail, especially in the transportation and the financial space. In which case you see a disaster recovery or a failover scenario with a given workload or a database being replicated across multiple clouds. That's something that when we get to the demo, Justin will touch on for sure. And that resilience to failure is baked into that. So it's reducing the vendor dependency, but also the dependency on the things that aren't human. You know, the machinery underneath, the network connections, the distributed denial of service attack that might hit one vendor harder than another vendor, or at different times perhaps. And then the last one is really just, you know, as an exercise in large industry, the result of mergers and acquisitions. You buy a company, and that company comes with its own dependencies, its own preferences for lots of things. Maybe it's the brand of office equipment and chairs and conference rooms, but that company also comes with its own preferences around software as a service and public cloud or private cloud as a service. There's a lot of nuance in each and every one of these. I'd ask if to please raise your hand if at least one of these did not strike a nerve with why you would go multi-cloud. Okay, I've successfully gotten no one to raise their hand. That's a little anticlimactic. Okay, so now we're going to move into sort of a second segment of this talk, and this is, I'm going to call this the chalk talk. I actually created these slides while I was watching March Madness, the NCAA basketball tournament, and I love basketball, and I'm always inspired by a coach that'll, you know, take off their jacket and really get down with the team and coach from the bench. Okay, so now we're into chalk talk. And we're going to start with a couple of formulas. We're going to do this as a math chalk talk. So this isn't a basketball chalk talk. This is a math chalk talk. Maybe I'm talking more to the tech audience about math than basketball. I don't know. I think I crossed both of those. So the formulas start here. We're going to start from here and build up. Containers is something that I don't need to explain to this crowd anymore. 4 or 5 years ago, I think we would have had to have where did containers come from? Was Docker first or Solaris Zones first? But I think this is all well understood at this point. And when it comes to multi-cloud, there's one thing that containers gives you that's absolutely essential to everything you want to do in a multi-cloud environment, and that's portability. The ability to move your code, your workload, your data from one place to another, physical or virtual or otherwise, from on-prem to the cloud and back and forth, from your developer laptop in the coffee shop, pushing to the build system, pushing to cloud A, cloud B, cloud C, when you fire one vendor and you buy another vendor, being able to move that. And containers are at the heart of that. And yes, virtual machines have always been able to sort of move between clouds. But it's really containers that got the concept and boiled it down to its simplest and most critical definition, which is an application, some code that you bought or you wrote that bundles its dependencies and everything it needs to run. And because it's in that atomic unit as an image, it can now move anywhere. And it was containers and Docker containers that really democratized that technology and put that into the hands of everyone. There were a lot of companies that were doing container-like things for decades. But this tectonic shift in the landscape happened 4 or 5 years ago, about 2014. Now, once you have a lot of containers, like containers to the containers power, right? You've now got a problem. You've got a lot more machines to manage than you ever had in the physical world. More things to configure than you ever had in the virtual world. It's really an exponential, truly an exponential problem. And it's Kubernetes that happened about that same time, 4 or 5 years ago, that it actually provided proper tooling to be able to handle that exponentially more complex scale and scope that containers introduced into your enterprise. I've certainly spoken with a number of executives who now look back on that moment when they realized they had this problem of sprawl. Sprawl of code, maybe there were licensing issues or support issues or otherwise, and now being able to manage that from a single place where Kubernetes sort of came in and helped with a lot of that. Now, I think you know Kubernetes is built on decades of experience at Google managing upteen illions of containers over the years on Borg as jobs, as persistent services, and we've made that available to the open source community in the CNCF, the Cloud Native Computing Foundation, but certainly as a product from Google as well. And that's the Google Kubernetes Engine. Now, as I alluded to earlier, last year as we tackled the hybrid cloud problem, we brought GKE, Google Kubernetes Engine, which we've run as a hosted service, managed service inside of Google Cloud. We ported that to run inside of the private data center. Anywhere that you have a vSphere with the appropriate number of physical and virtual machines, we can stand up a Google Kubernetes Engine on-prem, GKE on-prem, inside of that enterprise data center. And we're working on extending that. We're working on bringing that to other environments as well, beyond our starting point, which we've established, and it's working really well. But now we're starting to gather that feedback from those initial customers as to where else they want to take Google Kubernetes and use that elsewhere. So now you've got a bunch of Kubernetes, a bunch of clusters, and inside of that you've successfully deployed X to the Y containers, and you're scheduling and scaling them up and down, and that's great. So you've actually gone multi-cloud at this point. But by this point in the talk, if you followed and implemented that, you've now got Kubernetes running in multiple places and managed that. Congratulations. And you've deployed a bunch of services into that. You haven't done that just for the exercise of doing that. You've actually deployed work into each and every one of those. And once you've done that, you now have services that need to talk to other services. You have humans that maybe need to talk to some of those services, but you probably have a lot of machines and other services that need to talk to other services. And that's ultimately the problem that Istio solves. Istio is part of the Kubernetes family. It's another open source project started at Google that ensures that services can talk to other services and do so securely. It's called a service mesh, and it handles a lot of the complexity around generating certificates and the certificate management, the securing of services in both directions from one to another. And this is a big problem. Without something like Istio, distributing certificates and ensuring that root of trust from one service to another is that problem space is ripe with a lot of different solutions, many of which are brittle and or homegrown, or just weren't really designed for the cloud native nature of containers. But Istio was, and that's exactly what we hear from customers saying that every day they're using to reduce the complexity of communication between those services. So Istio is often used in conjunction with another project, another open source project called Envoy. And Envoy handles the spreading of network across a bunch of services, both inbound from a proxy and load balancing perspective, and it's really about the inbound at this point. So being able to handle service, those microservices, and the traffic going to those microservices, and route that traffic appropriately using load balancers and tie it into. Now, there's a lot of different ways that you can and will use load balancers in your clusters and in your Kubernetes. Envoy is one of them, and it's natively part of this sort of ecosystem. And these are quite useful in handling that traffic. Now, serverless, or functions as a service, is another methodology that's often employed in MultiCloud. And KayNative is another project that we've implemented on top of Kubernetes. So we use Kubernetes as a base, and then we've implemented a serverless engine called KayNative that sits on top of Kubernetes. And it can sit anywhere Kubernetes runs. And what's important here is that many of the serverless engines feel certainly like a vendor lock-in. It's something that's native to that cloud, and it's something that you want to use and you need to use. But if you're still staying true to that multi-cloud strategy, you might be caught in a bit of a bind. But KayNative is how you can actually continue to use functions as a service or a serverless engine and avoid that vendor lock-in. This is important to staying true to that multi-cloud strategy. Now, part and parcel to every single containerized environment, especially in the multi-cloud, is a good CICD system, continuous integration, continuous development, ensuring that your developers can write some code, build that code, test that, and deploy that across multiple clouds. I mean, you've just blown out your matrix, right? Now that you have to be able to run that same code anywhere, you need to ensure that you can test that same code anywhere. Generally, containers will handle the portability, and it'll ensure that you can move your code from one place to another. But you need to be able to very quickly detect where someone somewhere has baked in an unexpected dependency on something that may not exist somewhere else at some point. And that's where something like Cloud Build or any of a number of CI/CD, continuous integration, continuous development platforms on top of Kubernetes can help with that. And it's all baked very nicely into Kubernetes, which handles the scheduling of the new container that builds your code and maybe runs your code and then spits out those test results into a comprehensive view. And speaking of view, it's hard to talk about multiple clouds without at least thinking about what a single pane of glass might look like. So ensuring that you have a single pane of glass across multiple estates, perhaps on-prem in one cloud, Cloud 2, Cloud 3, and in your own private clouds, is also something that we hear all the time is just fundamental to implementing a multi-cloud strategy. And so we have that. It's called the Google Cloud Console. And from that Google Cloud Console, which Justin will certainly show you, from that single Google Cloud Console, you can see multiple clusters. You can access those clusters. You can deploy workloads and destroy workloads and scale those workloads all from a single UI. And it's a graphical user interface, but there are good command line tools and APIs, certainly for every one of those. It's just one of our sort of guiding principles. And this all works because that Cloud Console aggregates all of the information about your clusters into a hub. We call that the GKE hub. And it's because inside of every cluster, there's an agent that authenticates with your account and communicates with that hub and provides the information, the control information, the metadata information about that cluster so that the console can render that for you. It also receives the messages that you post there asking that cluster to do something. So it's bidirectional. It's bidirectional communication. And you're able to do that with with a single unified view across your entire estate anywhere in the world. And one of the things that I think we see more used than anything else inside of that single pane of glass is the log aggregation, the monitoring of all of the clusters anywhere. We provide some really first-class monitoring and logging solutions in Google Cloud with Stackdriver, and we integrate with a number of others. You can certainly run your own Elk stack, Kibana, Elastic, and you can run your own Prometheus or Grafana, and many of those run natively, all of those run natively as containers inside of Kubernetes. So once you have a Kubernetes, you can deploy those as workloads inside and then use those to monitor. And so being able to do that with any cluster, anywhere, aggregate that and process those logs, trigger on failure, learn from those logs and train your models so that you've got predictive ways of avoiding problems in the future. But doing that across multiple clouds is quite remarkable, and that's something that we'll see here in just a second. And then, managing those clouds, and especially those clusters, managing the configuration across those clusters, being able to comprehensively push out a security policy across many systems and combine those into new and interesting and secure ways is essential and just really part of ensuring that you've got a multi-cloud story that is secure and that you're able to roll out an update to that policy everywhere. So config management is also part of this platform that I'm describing. And I'll leave this last one before we sort of bring this all together. We've also got something called the GKE Marketplace, and it's a marketplace of solutions, software solutions, containers ultimately, that can run originally in your GKE clusters, the clusters that you run inside of Google Cloud. That marketplace and all of those solutions, and that's a factorial, not an exclamation point, all of those solutions there come together and you can deploy those. There are open source third-party solutions, there's commercial software, there's Google-provided software in that marketplace. You can deploy those in new and interesting ways on-prem, in Google Cloud, and now in other clouds. And this is, all of these together, the sum total is ultimately the thing that hopefully you heard about this morning, which we're calling Anthos. Anthos being a new platform. It's truly a platform that crosses hybrid and multi-cloud. This is how you actually solve the hybrid and multi-cloud problem. Modernizing your applications as containers, enforcing the security around the policy, and doing so at scale on premises, in our cloud, and in other clouds. That's what we've set out to build here. Graphically, it looks something like this. I touched on a lot of these hexagons over the course of our little math tutorial here, but this is how we're seeing this ecosystem evolve. This is the combination of services necessary to bring together a platform that moves from one place to another and has that persistent experience. And with that, I think I'll leave us with just sort of a thought that the ethos of Anthos is that it's a common language across any cloud. It's how things move from one place to another. And in that way, it's a lot like math. Math is a common language no matter where you're from. It's constant. It's consistent. It's something that we can all relate to. We don't get to change it. It's not something that we get to have opinions about. There's facts. And that's what we've set out to build, a common language that operates across clouds. And so, at this point, as in any good Google talk, we're going to have a live demo that my colleague Dustin here will lead. You want this?
Sure. Thank you.
Yeah.
Thank you, Dustin. That was great. All right. I'm going to try to show you in this demo sort of how we put those formulae into practice. You could say I'm going to sort of plug some numbers into the equations that Dustin presented. Quick outline of what we're going to do, because we're going to go through pretty fast when we actually get to it. We're going to show how containers and Kubernetes give us portability across clouds. We're going to hit a bunch of different Kubernetes clusters in different clouds. We're going to look at that single pane of glass, the Cloud Console, so we can sort of get visibility into our workloads and our clusters wherever they are. We're going to show how Istio gives us the ability to understand what's happening in terms of services and also gives us connectivity across those different clusters. We're going to look at logging and tracing information across those clusters again through Stackdriver. We're going to show configuration management. We're going to use that to do what I hope is a pretty cool move, which hopefully wake you all up a little bit. And then we're going to dig into like how you can pick services from around the web, focusing on BigQuery, which is a good service that Google offers, and also then the Marketplace, which is a way to get services that other people may offer. And with that, let's construct our example here. So we are, in our scenario here, we are going to, I might have to debug Linux display on the fly, which is always challenging. Hold with me for just 1 second. Mirror, apologies. Does it look okay? Yay. No applause, not even for that. I should say a lot of these things that we're showing, thank you. A lot of these things we're showing this week are very new, so if this does all work, then definitely that does warrant a round of applause. In our example, we're going to pretend that we are an e-commerce retailer, and we have a fairly traditional multi-tier app. We have a web front end, which serves our web and mobile app users. We have a product catalog component, which stores the descriptions of the products that we're selling. We have an ERP system that runs on a mainframe that really powers our business. And although we've put an ERP gateway in front of that mainframe, that really keeps everything on-prem right now. But the web front end communicates with the catalog to serve browsing traffic and with the ERP system for the actual orders. We have started, everything is running on-prem because of that ERP system on the mainframe, but we have started to adopt Kubernetes in the data center. And we've been using GKE on-prem, which is great because it will make this a lot easier going forwards. And we are starting to run our workloads in portable containers. Now, this isn't really what people would consider multi-cloud yet, of course, but that data warehouse is actually running in the cloud. We can run BigQuery, for example, and tie into cloud ML and AI functionality. And so already in this example, we have some multi-cloud. We're already choosing the best capabilities wherever they're located. So I suspect that actually, if we go out there, most of you are already doing multi-cloud to an extent today. And similarly, if you think about how you do DevOps today, you're probably doing that not all in one data center where you're running your workloads. You probably have that spread out across multiple locations. How are we doing DevOps here? Well, let's get to some code, right? So here we have the code that powers this demo app. It's in a Git repository hosted on Google's cloud source repositories, but you might be using GitHub, for example. But you can see our different components. We have our front end. We have our catalog service. We have our ERP with the ERP gateway there. And whenever I push whenever I push code to that, we trigger a build. Here for our CICD system, we're using Cloud Build. And you can see I have a trigger. And so whenever I push, a build fires off in the cloud, which is great in terms of burstability. And you can look at some of my previous builds, some from more recently than I care to admit. And when I dig into it, you can see that they actually, this build succeeded. And the output of this was 3 container images. Those portable container images, which we're going to run on Kubernetes again. And those are actually automatically pushed into the container registry here. So here you can see, for this container registry, for this example, I'm running on Google's container registry. But again, you could run wherever you want. Note that our Kubernetes cluster is running on-prem, but our container registry is running in the cloud. I think everyone should be familiar with this, but it is something we are able to do. And that's actually pretty impressive, and that's done by containers and Kubernetes. All right. And whatever offerings you want, GCP obviously has great offerings, but you can mix and match with whatever you choose. That's sort of the power of, or the promise of multi-cloud. I think that's pretty good from a developer perspective. We have a fairly nice push-to-deploy pipeline going there. But let's talk a little bit about the sort of operational side, the observability, which is sort of the right-hand side of the slide here. So let's look at our Kubernetes clusters. So you can see here that in Google Cloud Console, we have a bunch of Kubernetes clusters that appear even if they're not running GKE. So we have here a GKE cluster, which of course appears. We have a GKE on-prem cluster, which appears. And we have a Kubernetes cluster that isn't GKE at all. It's actually running in AWS. We built that using kops because the team is pretty cool, but you can use any open source Kubernetes cluster you want to. So we'll come back to the 2 cloud guys in a minute. But let's have a little look at what we're able to see on the on-prem cluster through the Cloud Console, even though it's running on-prem. So you can see we can like look at our nodes, get basic observability of that. But we can also look at the actual workloads that are running on-prem. And you can see on the right there we have our 3 clusters, or three workloads, but they're all running on-prem. We have our front end, our catalog, and our ERP gateway. And that's despite the fact that this is, again, running on-prem and we're looking at it through the cloud. All right, but let's now see what other information we can get. Let's have our first look at the app. So this is the app running on-prem. You can see the on-prem in the URL there. And I click around my example app, which I invested a lot of time into. And we've generated some traffic. So now we can again switch to Stackdriver, where we should now start to see through Kubernetes and Istio a lot of the information that is coming in from our app. All right, we don't have as much as I thought, but you can see, for example, that here is a request. Let's see, a web request. It looks like that hit the front end, and you can see that it is the resource is a Kubernetes container, and the cluster is on-prem. It's running on-prem, and the other one will presumably be the back-end service that satisfied that. Let's see. Yes, the catalog service. There we are. You get all the logging type views. Stackdriver has some nice views on this. I think my favorite view is the tracing view. So if you want to really understand what's going on in a sort of multi-tier service, let's see. It felt a little. Might generate a little bit more traffic. Let's see. There we go. That worked. All right, there. So you can see here we have a trace view, which is a distributed trace across the various tiers of our application. So we hit the front end there, and we hit the catalog service there. And you can see on the sort of details here that the cluster is once again on-prem, because of course everything is still running on-prem. But despite the fact that it's running on-prem, again, we're looking at all that information through Google Cloud Console in the cloud service. All right, so this has all been sort of multi-cloud, but mostly for running the cluster. Let's move our data plane. Let's move our app itself across multiple clouds. We have those clusters sitting there. Let's use them. We would like to have the choice to run our website somewhere in the cloud to better handle spikes, as we were told earlier, and to put it in geographies closer to our customers. So we made a great move by putting our app in Kubernetes. So it should be relatively easy to move everything to the cloud, except for that mainframe dependency, which is sort of keeping us on-prem. So we're going to have to figure something out, and Kubernetes and Istio now to the rescue. So we are this is our current scenario. Everything is running on-prem, and we want to do this slightly difficult trick, which is to split our application across with the front end running in the clouds, in 2 different clouds, in fact, and tunneling that traffic back to the on-prem cluster. This is a Kubernetes environment, so you could just use kubectl to do this, but you notice I actually drew a box at the top for configuration management with a big arrow, and this is what configuration management makes easy and lets you do declaratively. So I'm going to show you just how easy that really is. We have a source repo, again, another Git repo, again in cloud source repositories, but it could be anywhere. And you can see we have our clusters described in here, and we have a couple of selectors. This is configuration management. We have a couple of selectors here that, for example, the on-prem selector says only the on-prem environment, whereas the selector all says the environment can either be on-prem or cloud. And you can see we have our 3 tiers, front end, catalog, and ERP described right here. Okay, I will first show that there is nothing up my sleeves. I actually don't have sleeves today, but there we are. So we have an AWS URL, which is obviously not working, and a GKE. Sorry, did not mean that. We have our cloud ones, which are not yet working. I will now edit the policy to deploy. Let's see. So there are a selector on-prem, and all we have to do to move this front end, the front-end Kubernetes applications from on-prem to all our clusters is to basically change the selector. We're going to change it from selector on-prem to selector all. We will save, we will git add. So there, in case you missed it there, changing from selector on-prem to selector all. We do a git commit, deploy front end to all clouds, push. We are pushing. Okay, and now if I'm fast enough, that workloads view that we had before, let's see, yes, I beat it, okay. We should shortly see, it was not a challenge to beat this. We should shortly see the front end deploying. There we go. So you can see that the front end is now deploying to these 2 additional clouds, AWS and GKE. Of course, it's already running in on-prem. If I refresh, you will see that, of course, oh, it's good. All right. If we hit this, it's still not going to work, but we're going to get closer. So you can see that we have some errors about upstream connect errors. If you know gRPC, this is about cross-service connectivity. And the reason is that we haven't actually made the cloud clusters able to connect back to our on-prem system. This is where Istio comes in. So we just need to change the endpoint for our catalog service. Istio is able to do multi-cluster routing, and we change it from the Kubernetes internal name to the name we gave the multi-cluster service. We change it, commit, use Istio multi-cluster service. Let's push that. And again, we should see, if I'm fast enough, we should see it start to deploy again or roll out the new configuration. We might miss this, but let's just go. Not yet, let's watch it. There it goes. It is rolling out on AWS first, it looks like. There they go. It's rolling across all 3 clusters. And just wait one more time. Looks like we should be close enough. All right. We are now running on AWS, and we have our website running. It is going over Istio back to our on-prem cluster, talking to our ERP gateway, talking to our mainframe, and we can click around as before. And of course, we can also run it on GKE. And there we go. And even more magically, of course, our logging still works. Although now we're able to see, if we click down and get lucky, that we are running in, that's still on-prem. We are running in multiple clusters. There, okay, well, I won't keep guessing. Let's look at the trace view. The trace view is much easier to understand. So here we are. So let's look at this one, which took a while. Let's find a good one. There we go. So here we are. So here we have one that started off in the AWS cluster for this top one, and then the catalog service was running in on-prem. So we managed to cross that. So I think that's pretty cool. Yeah. All right, and I will close this out with a quick look at the other pieces. So the idea of sort of business metrics. BigQuery is a great solution for business metrics. So we're streaming our sales pretty much live into BigQuery right now. And if I do this a couple of times, you can see if you look very carefully that the timestamps should be changing. There they are. They are changing. And of course, because it's BigQuery, you can then build a fancy dashboard, maybe. And I can refresh. And the order count should go from 3. The order count went up. So this is indeed live data.
2 million during this demo?
That's yes, exactly. When you make it up, you can make good money. And BigQuery is of course a great system. But if you wanted to look at other solutions from other vendors, if for example you wanted to get your CRM data going into BigQuery, for example, there's a marketplace solution for that. You can install it just like that, and maybe you have a pricing engine that runs on Spark. And so in the marketplace, there's a Spark operator ready to go. We can choose to configure it. We can choose to deploy it. And of course, we can deploy it onto our GKE cluster. Of course, we can deploy it onto our GKE on-prem cluster, but we can also deploy it onto our Kubernetes cluster that is running on another cloud on AWS. So you just hit deploy, and it's that easy. So that is a very quick outline of containers giving portability across clouds, Kubernetes, the single pane of glass, The console being able to see everything everywhere, Istio being able to power the multi-cluster traffic, Stackdriver to give us a view across all those clusters, configuration management so that we were able to deploy workloads moving from just one cluster running on-prem to multiple clusters, perhaps even more easily than running a single cluster, BigQuery for business metrics, and the marketplace to deploy solutions onto any cluster anywhere.